Hello viewers, in today's class we are going to discuss yet another very important and conceptual problem from limits and continuity, right? And here we have a very important problem which is a good problem for the beginners, right? So here we are going to use the concept of greatest integer function and the mod function, right? So here our problem is to find the right hand limit and the left hand limit of this function, right, when x tends to 4. So here the function f of x is equal to e raised to greatest integer of x minus 4 divided by cosine of mod of x minus 4, right? So here we see that both the important functions, that is greatest integer function and the mod function, are involved, right? And here e is the exponential number. So let us start and let us first find out the right hand limit of this function when x tends to 4. So now the notation for the right hand limit is RHL, and we have limit x tends to 4, and here we'll write a positive sign, right? And here we'll write f of x. So this positive sign shows that x approaches to 4 from the right of x is equal to 4, right? So here we have the number line and here we have x is equal to 4. So when we calculate the right hand limit, then it implies that we are approaching from the right of x is equal to 4, right? And when we are calculating the left hand limit, it implies that we are approaching towards x is equal to 4 from the left of x is equal to 4, right? So here to the left of x is equal to 4, we have the point x minus 4, or we can write this point as 4 minus h, right? And here to the right of x is equal to 4, we have a point that is 4 plus h. So 4 minus h and 4 plus h are the points which are adjacent to x is equal to 4, right? So 4 lies between 4 minus h and 4 plus h, and here 4 minus h and 4 plus h are the points in the neighborhood of x is equal to 4, right? So now here we can write limit and x tends to 4 plus, and for f of x we can now write e raised to greatest integer of x minus 4 divided by cosine of mod of x minus 4, right? So now here we'll make use of the method of substitution. So we'll take x is equal to 4 plus h, right? So here we have this point 4 plus h, and when x tends to 4, then obviously h tends to 0, and this quantity h is a positive quantity and it lies between 0 and 1, right? So h is a very small quantity. So now if we convert this limit in terms of h, then we can now write the right hand limit as the limit h tends to 0. Now for x tends to 4 plus, we can now write h tends to 0, and we have e raised to greatest integer of x minus 4. So for x we can now write 4 plus h, and here we have minus 4, and in the denominator we have cosine of 4 plus h minus 4, right? Now let us simplify this expression. So we have limit h tends to 0, and this 4 and this 4 get cancelled, and we are left with greatest integer of h, and here we have cosine of mod of h, right? Okay, now see here in this step we cannot directly substitute h is equal to 0, right? So here we have to take care of this greatest integer of h, right, and mod of h, right? So see h, it lies between 0 and 1. So from the definition of greatest integer function, if a number lies between 0 and 1, then its greatest integer should be equal to 0, right? And mod of h is simply h, because h is a positive quantity, right? So here we have positive h. So now we can write limit h tends to 0, and here we have e raised to greatest integer of h, that is equal to 0. So here we have 0, and here we have cosine of h, right? Because mod of h is equal to positive h, because h is greater than 0, right? So this is due to the definition of mod function. So here we have limit h tends to 0, and e raised to 0 is equal to 1. So we have 1 over cosine of h, right? So now when h tends to 0, cosine of h tends to 1, right? So here we have 1 over cosine of 0. So we have 1 over 1, because cos of 0 is equal to 1. So that is equal to 1, right? So the right hand limit of this function when x approaches to 4 is equal to 1, right? Now let us find out the left hand limit. So now viewers, the notation for the left hand limit is the limit, and here we have x tends to 4 minus, and here we have f of x. So now we can write limit x tends to 4 negative, and for f of x we can write this function, that is e raised to greatest integer of x minus 4, and here we have cosine of mod of x minus 4, right? So now when we calculate the left hand limit, we are approaching from the left of x is equal to 4, right? So in this case, we have this point in the neighborhood of x is equal to 4, but it is towards the left of x is equal to 4. So here we'll take x is equal to 4 minus h, and the other conditions remains the same. So when x tends to 4, obviously h tends to 0, and h lies between 0 and 1, and h is a positive quantity, right? So now we can transform this expression in terms of h. So we have limit h tends to 0, and here we have e raised to greatest integer of x minus 4. So for x we can now write 4 minus h, and here we have minus 4, right? And in the denominator we have cosine of 4 minus h minus 4, and here we have limit h tends to 0, and e raised to, here 4 and 4 get cancelled, we have greatest integer of minus h, and here we have cos of uh, mod of minus h, right? So now again we have a very important step over here. We cannot directly substitute h is equal to 0, right? But we have to take care of the expressions, that is greatest integer of minus h and mod of minus h, right? So mod of minus h is simply positive h, again due to the definition of mod function, because h is here greater than 0, and the greatest integer of negative h is equal to a negative 1. Why? Because see, here we have h lying between 0 and 1, right? So if we multiply throughout by negative 1, then we'll get 0, and the direction of the inequality get reversed. So here we have minus h, and here we have minus 1, right? So this inequality can also be written like this, and we see that minus h lies between minus 1 and 0, right? So here we have minus 1, here we have 0, and minus h, it lies somewhere between minus 1 and 0. So from the definition of greatest integer function, the value of greatest integer of negative h must be equal to negative 1, right? So now we have limit h tends to 0, and e raised to, here we have minus 1, right? For greatest integer of minus h we have minus 1, and here we can simply write cos of h, right? And we see that e raised to minus 1 is 1 over e. So here we have 1 over e, because this is a constant, we can take it outside the limit notation. So we have limit h tends to 0, 1 over cosine of h, right? So we have 1 over e times 1 over cosine of 0, because when h tends to 0, cos of h tends to 1, right? So we have 1 over e times 1 over 1, and this is equal to 1 over e, right? So the left hand limit of this function when x approaches to 4 is 1 over e, right? And we have just seen that the right hand limit was 1, right? So we can easily see that the right hand limit and the left hand limit both exist, right? And they are finite, right? But they are not equal. So the right hand limit and the left hand limit, although both the limits exist, but they are not equal, right? So we can safely claim that here the limit of this function when x approaches to 4, it does not exist, right? Because the right hand limit and the left hand limit both are different, that is, they are not equal, or they are not approaching to the same value, right? Because this is 1, this is 1 over e, and 1 over e is not equal to 1, right? So the limit of this function when x approaches to 4 does not exist.